Hello. Hey. Oop, shoot. My bad. Hello. We good? Hey, Max, how are ya? Can you hear? Okay, looks good. Okay, audio good. Sound, audio good. Video good. Okay, excellent. Excellent. We got Max here. Is everything alright? Hey, Nick, how are you? Hey, Nick. Does everything look good? Everything sound good? Alright, sounds good. Excellent. Hey DF, how are ya? Excellent. Okay, we've got some viewers on. All right. Hey, hello everyone. Cool. Um, yeah, the reason why this is important because I'm on a new connection right now. I'm not going to get too much into details on the connection that I'm having, but it's a little different than what I had before. I'm still hardwired, which is good. I'm still hardwired, but there are some things that are different in my setup. So this is the first week with kind of a new setup. With a new setup. All right, so hello everyone. Welcome. We're back. Been how long has it been since we were off? How long have we been? We haven't been on Twitch for. It's been I feel like 2 weeks. Definitely been over a week because I know last week we didn't have any class and we said let's play capture the flag. So we're back. It's nice to be back. This is a kind of a messed up week because we are on Tuesday and not on a traditional Thursday because Thursday is a holiday. It's Veterans Day. Um, so at Tufts, the schedule for Tuesday is actually a Thursday. Uh, yeah, been too long, but all right. Today's one of my fun topics. It's actually a fun topic I really enjoy doing today. Um, the reason why I enjoyed today, I think for a lot of people will enjoy this topic a lot, especially if you like programming. If you like computer, if you like programming, definitely today is the day. Um, I'm going to start out probably first 15, at least a good 15 minutes. It's going to be interactive, and I'm going to show you something called bad code. Yeah, that's right, bad code. So I remember it was a week ago or 2 weeks ago, someone in my online masters class, in our online masters class said, is bad programming insecure programming? Or is bad programming uh, a sign of insecurity or vulnerabilities? It was a really good question. It was like, you know what? They usually go hand in hand. So, bad programming will usually lead, well, a lot of times, lead to security vulnerabilities. So, what have we done so far? We've done vulnerabilities, we've done web security, you've done CTF. Um, and the CTF game was all about finding vulnerabilities and, of course, taking advantages of them. But now, here we are this week. The CTF game is over. It's been fantastic. It's a lot of fun, a lot of fantastic for everyone. But now we're going to play a different game. So, in my security class, we played Capture the Flag. And now the game is over. Teams have to write the CTF report. There is a follow up. It's not the game is not entirely over yet, which that is. I actually give you the source code of the entire CTF game. Yeah, I give you the entire source code of the CTF game, and students have to find vulnerabilities now that are in the source code, not necessarily in that were not visible in the game. Okay, so all right, so this is what I'm gonna do. Let's get right to it. Let's get to talk about bad code. All right, so I got three options here. I have three options. I have C, I have Java, or I have JavaScript. Which one do you want to start with first? Java, JavaScript, or C? Ooh, okay, so Nick says Java. Anyone else? So your options are Java, JavaScript, or C. Okay, this is what we're going to do. Nick chimed in first, so we're going to start with Java. I'm going to start with Java first. Then we're going to go with C code. Then we're going to end with JavaScript. So here is what I'm going to do now. Let's see if I can. Wait. Now I'm going to open up bad code number one, Java. There it is. All right, can you see? There you have it. Here is example bad code Java. I'll give you a minute or two to peruse through this code. And you tell me everything that is wrong with it. I don't care if you know Java, the programming language, or not. But there should be a few things that should stand out right away. Okay? There's no validation on SQL. Whoa, what do you mean by no validation on the SQL statement? Which line? Point out the line number. Point out the line number. Oh, yep. Credentials and source code in the clear. There you go. Lines 4 and 5. This is not a 5-alarm fire, but this is like a 6-alarm fire. When you have the username and the password in the source code, as in, hard coded, this is just classic. What was it? I'm gonna fire this up. No, don't ask again. I'm gonna go and fire up, let's say CWE top 25. Yeah, this one is what you call not okay. This is a classic example of CWE 798 use of hard-coded credentials. This is bad. 4 and 5 is just god-awful. Line 13 is also god-awful. Why is line 13 just really bad? It's because there's no, well, first of all, there is no no validation of the SQL statement. You basically a string. This line number 13 is concatenating a SQL query with a user input. There's no validation of the user input at all. Okay, this is actually the classic example. Line number 13 is a classic example of how you get SQL injection, when you actually treat the user input as part of the SQL query. This is bad. All right, what else can you find that's wrong? Tell me another thing that is completely wrong. There's a whole bunch. There's actually a couple of other things that are wrong with this. Now I can think of 1, 2, 3 4 additional problems. Oh boy. Okay, line number 20. Line number 20. Why is that bad? Why is printing out the exact error message a really bad thing? That is a good one. I didn't think that wasn't one of the four that I thought of. Well, tell me why that guy 434. Tell me that guy 4348. Why is printing an exact error message not a good thing? Yeah, as Nick said, is the information gathering part. Especially when you're presenting out to users, you never want to throw out you never want to throw the entire error, print out the entire error. That's not good. Way too much information. Yeah, exactly. I mean, it offers insight into the exact technology stack, the internals of the server, and the protocols that are being used. Worst comes to worst, it may even actually expose parts of the source code. This is not good. Okay? Anyone else? What else can you find that's terribly wrong with this code? I can think of at least three or four. All right, the big ones are we've already talked about hard coded credentials, lines 4 and 5, SQL injection, line number 13. Okay, line number 20, information, it's just printing out an entire error message as is, which is just bad form. Um, Other things I can definitely think of. Number one, line number one is a code quality issue. Is Java dot import Java dot SQL dot star. Star means wildcard. The problem with that is um, the star is import everything from the Java dot SQL package. You can actually be a little bit more specific because if you do import Java dot SQL dot star, it imports everything. Of course, you have a perhaps a performance and memory issue there. Okay, you only want to import the stuff that you really need. That's a code quality question. Yeah, I mean the exposed IP address on line number 10. Again, that's also another code quality issue. If you actually want to actually have connection information, things like okay, so let's now talk about how to fix these problems. Username, password, um, username, passwords, connection information, that should all be stored in memory. Shouldn't be hard coded ever. Should never be hard coded in source code. You always want to store them in what you call environment variables. Okay? So, Java use environment variables. So environment variables that are stored on the system. Alright, so here it is. Here's the documentation from Java. Okay, many operating systems use environment variables to pass configuration information to application, like exactly what we're doing. Like properties in Java platform, it's key value pairs. So all you need to do is on your system, save your username, password, and the URL in what you call an environment variable. Store them in memory. Then you just on the Java platform application use system.getEnv to retrieve environment variable values. Stuff like this. So even if someone, let's say for the sake of argument, if someone actually gets a hold of your source code, like here, you won't get the username, you won't get the password as is, and you won't get any connection information as is. So yeah, Nick is correct. I mean, exposing the IP address and ultimately the connection URL is not a good thing. The other big problem is there's also a problem. I know hard coding username and password is a bad thing. Line number 4 in itself is also bad. What's the problem with line number 4? There is also an additional problem. Line number 4 is a problem of its own. Forget about line number 5, but forget about line 4 and 5 together, but line number 4 is just bad form. Really bad. The username is what? It's root. So if you're a root user of in this case, a database, what privileges do you have? Yeah. A root user means you have access to everything. It's a super user. So when you actually are managing a database, you never ever want to use root to connect to everything. There's a security principle called the principle of least privilege, which is you want to create a user with the least possible amount of privileges to do a job. Okay? Should not allow a username to be. Yeah, that's it. Is the way you resolve this problem is create a database user of some sort that is not root. Let's say like Twitter underscore app underscore user instead of root, which only have permission to like do a select or insert. That's it. Root has all the privileges in the world. Root have all the privileges in the world. So remember, someone get a, in this case, someone gets a hand of the username root and the password of the root user. Now the user, whoever the attacker is, get access to all the database, all the data, all the privileges, and then some. Everything. Yeah. Mm-hmm. It's the same idea with that guy. You never want to be root. I mean, least privilege is important. Create a username that only have certain amount of privileges for the app to do the job. Less is more. Okay. Having a root user, no, no, no. Even now, a lot of even Linux systems actually have prohibited the idea of eliminated the idea of having a root user. Even Kali Linux said no more root user at all. Another problem I can think of is another problem is here. One of the things is I don't think a lot of people, if you've never worked with databases before, this may be hard to see, but if you have worked with databases before, when you open a connection, what do you also have to do at the end? And I ran into this problem a lot during my day job years ago. Okay, if you never worked with a database before, fine. I'm sure a lot of people actually have worked with files before. So if you take an introduction to computer science and you actually have to do something called, what is it? You have to open a file. You open a file for reading, but at the end you have to do what? You have to close the file. Same idea with a database. When you open a database connection, you also have to close the database connection. There's no closing of the database connection here. So one of the things that you need to do at the end is to have like a finally clause after the catch. Okay, at the very end, no matter what happened, close the database connection. That's missing. But the two big ones, the big issues are 4 and 5, and line number 13. Line number 4 and 5, username and password in plain text. You always want to store the username and password in environment variable. Never hard code that into source code. Line number 13, you want to actually fix line number 13 for SQL and SQL injection. This one's 13 is instead of doing the string concatenation way, look up Java prepared statements. I spelled it wrong, but oh well. Here it is. Sometimes it's usually more convenient to use prepared statements for objects sending SQL statements to a database. This type of statement is derived from a general class statement that you already need to know, yada yada yada. So what it is variable binding. So instead of doing any string concatenation, you know, your whole SQL query is a string, but any variables has a question mark. And then what it does, in your code, all you need to do is like set int, set string, set, and then the index value for the first of the question mark, and then the value. So no more string concatenation crap. No more string concatenation stuff like you do here. The idea in line number 13, you want to use prepared statements. Alright, the one last thing is we didn't talk about line number 20. I forgot who it was. That's, I think, who said line number 20? Yeah, that guy also said line number 20. When you do logging, okay, when you do instead of system to print out, okay, for the general user, all you need to say is, whoops, something's terribly wrong, and that's it. Stop there. However, you should use like a logging system. In any good programming language have a logging system. All you need to do is set up a logging system behind the scene that just log the entire error. For the general user, all you need to spit out is, whoops, something went terribly wrong. But behind the scene, for your debugging purposes, log all exceptions and other big problems with technical details to stack to a log. there's so many logging systems out there that we can use. Okay, the 6 alarm fires, definitely line number 4 and 5, and definitely line number 13. So this is a Java example of bad code. By the way, if anyone if anyone is actually has any aspiration to do application security, um, usually what they do in an app at an interview is a little different than a traditional like software engineering interview. But if you're doing application security, one of the things that is very commonly done at interviews is they show you here's a whole bunch of bad code. Here's a bad code. Here's an example. You tell me everything that's wrong with it. Amazon does this. You want to work at Amazon and application security, that's what they do. And actually, that's what they did for recruiting at the B-Side Las Vegas conference in person the last time I was there. Just to let you know. All right. So let's done. Okay, so we did a Java example. Let's do C now. You ready? All right. So I'm actually going to go in a Linux box here. You can all see? More vuln.c. There you go. Boom. Here's an example of really, really bad C code. You tell me what's wrong with it. What's the vulnerability? If you ever worked with C before and you gotta know this vulnerability. You gotta pick this one. Okay, so we have apathetic Fox and that guy. We could easily over the buffer with stir copy. All right, hold up for a second. I want to ask both apathetic Fox and that guy, where did you learn not to use stir copy? Where did you folks learn not to use stir copy? I'm very curious. Okay, so you just figured that out. So, okay. So no one ever taught you not to use stir copy? Seriously, apathetic Fox, really? I want to show you this. Here's a good page. Okay, folks. Don't make a fool out of me the next time when you work with C. Here's a page from CERN. Gary McGraw called stir copy one of the dirtiest of the dirty C functions. I repeat, there is a slew of C functions that is called the dirtiest of the dirty. And here's from CERN. Most vulnerabilities in C are related to buffer overflow and string manipulation. In most cases, this results in segmentation fault, but are specifically crafted malicious input values adapted to the architecture of the environment could yield arbitrary code execution, and the list goes on. Gets. The standard I/O gets function does not check the buffer length and always result in a vulnerability. Mitigation. Preferred using fgets in dynamically allocated memory. Here you go. Stir copy. Stir copy function, strcpy built-in function, does not check buffer length and may very well override memory zone contiguous to the intended destination. In fact, the whole family of functions is similarly vulnerable. Stir copy, stir cat, stir compare. Vulnerable code. There you go. Mitigation. The best way to mitigate this issue is to use stir length stir L copy if it is readily available. Which is only on the case of BSD system. However, it's very simple to find it yourself as shown below. There you go. Another and maybe a slightly less convenient way is to use stern copy, which prevents buffer overload, but it does not guarantee null termination. For others function in the family, the N variants are in stern and stern compare. So now you know never to use stir copy. There's no buffer checking. And that's the one problem with a lot of C function, when C was never designed with security in mind. You can do whatever you want in C. It's both a blessing and also a curse. Alright. It's also printf. Alright. Want to see this in action? Watch what happens. GCC minus O bone.c. Now this is a straight Linux system. This is a Raspberry Pi ARM GNU Linux. Sounds good? Watch what happens. If I do bone, okay, there you go. Oh, I'm going to do more bone.c. Now take a visual snapshot of this code. So what we're trying to do is copy buffer 1, the word 1 into buffer underscore 1, which are of size 8, and also the word TWO, the string 2, into buffer 2, which is also of size 2. Then what we're going to do is just copy a whole bunch of user input into buffer 2. Let's see what happens. Bone, you have a user input of AA. So far so good? So far so good, right? Alright. Let's do 3 A's. Alright, looks good. 4 A's, looks good. 5 A's, okay. 6 A's, okay. 7 A's, okay. Uh-oh. 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 Now we are starting to have problems. Do another one. See a problem? Alright. So you notice that now, after a certain number of A's, buffer underscore 1, and the value at, well, that memory address is no longer 5. Buffer underscore 1 and that integer value becomes a mess. Can anyone explain why it is 0x61616161? What's the significance of 61? Lowercase a, there you go. 61 is the ASCII value for lowercase character a. This is what happened when you use stir copy. Now, this is a Linux system. I don't need this anymore. Now, if you're on a Mac, it works a little different. Watch what happens if you try to do gcc bone.c. If I try to use the GCC that's built for Mac OS. You got a warning. I didn't get that warning in Linux on a Raspberry Pi. Watch what happens if I try to run this on Bone. And systems. Some compilers, some good compilers will say, when I actually, and anytime you try to go overwrite the buffer, we're stopping the program of the execution automatically. So the real culprit of this vulnerable program in C is certainly the stir copy. It's stir copy. strcpy. There's no bounds checking at all. Okay? So on the first example, in the Java example, we had SQL injection, we had hard-coded usernames and password. Here in the C program, we have the use of stir copy. This is not good. All right, so now you know your lesson learned in C is never to use stir copy. One more bad code example. JavaScript. Ready? Let's take a look at server.js. Now this is Node.js code. This one shouldn't be too hard either. Take a look at this Node, this server-side JavaScript code, and you tell me what the problem is. You tell me what the problem is. And this one should be really glaring as well. What's the problem? There you go. The eval. What's eval does? Take a look. Let's do a search. What is the problem with eval? Eval. What is eval? Eval is evil. I repeat, eval is evil. Warning, executing JavaScript from a string is an enormous security risk. It is far too easy for a bad actor to run arbitrary code when you use eval. See below. Never use eval. This is from the Mozilla Developer Network. Eval is a dangerous function which executes code as passed directly with privileges to the caller. If you run eval with a string that could be yada yada, you may end up running malicious code on the user's machine with the permissions of your web page and extension. There you go. Never use eval. Unless you really know what you're doing, but still, don't have it. In other words, don't use eval. Alright. My favorite search is do a search for eval is evil. It's a running joke. Alright, so how is this evil? Why? Alright, I'm going to do node server.js. I'm going to run this as a server. What's the request method? Post, HTTP post. Listening on port 3000. Okay, that's not bad. And open a new tab. Curl minus data blah http localhost colon 3000. Okay, I got some data. So I sent blah a string to localhost at colon 3000 where the server is running from. And here's the server running. They received the data. Blah. Hi. What happened if I did this? Control C. What happened if I say baby shark? You get the idea. Got some data, baby shark, and what if I do 1 plus 1? Actually 2 plus 3. Okay. What happened if I do hello dot blank? Okay. Wait a minute. Let's do another example. What if I did this? console.log hi. Oh. Ooh, now we're getting somewhere. Console.log is like a print statement in JavaScript. Console.log hi. Ooh, but now it's like, ooh, we're getting something here. But let's take a look at the thing again. What if, okay, I see request and response are variables here. What if we did this? Instead of console.log a string, print out the whole request variable in Node.js. Print out the whole response in JavaScript. It's a lot of data here that, oh my God. All right, one last thing. Let's kill the server. One way is, if I'm not mistaken off the top of my head, process.exit. Kill the server. Boom. Done. That's what happened when you use eval. You use eval, evaluate data. Imagine if data is like JavaScript code. Could be anything. In this case, you send in process.data, process.exit. Kill the server. Ink droppings. Okay. Yeah, there is. Yeah, there's a Joe or 3 in the class. So here we are in this JavaScript example. Eval is evil. So we have in the Java program, we had SQL injection, hard-coded password, and a bunch of code issues. In C, we had stir copy, and here we are in JavaScript, we had eval. These are some of the dirtiest of the dirtiest programming practices around, which will almost always lead to security vulnerabilities. So what's the point? I mean, what's the point of me showing you all this stuff? Today, okay, so we've done 3 examples. JavaScript, C, and Java. The whole point is, okay, bad programming will almost always lead to security vulnerabilities. Also, if you're a developer or you're a programmer, one thing that you need to add to your arsenal of tools and your tool chain is called analysis. Okay, now analysis. Code analysis. There are 2 types. There is one called static analysis, which is my absolute favorite, and 2, dynamic analysis. There are 2 types of analysis. Static analysis, dynamic analysis. Static analysis is the easiest one for me to explain. What's the difference? No code execution. In other words, absolutely no running of programs. No code execution. 100% code coverage. To make a long story short, what static analysis really is code scanning. Using static analysis, all right, using a static analysis tool, it will just scan all your code. Every single line of code. Okay? 100% code coverage. But here's the problem. The thing about static analysis can easily catch Okay, glaring programming vulnerabilities. I mean, this one's easy, such as stir copy, eval, you name it. I mean, there are just things like using static analysis. It will just catch the dumbs, like the real dirtiest of the dirty stuff, like the use of stir copy, use of eval. Okay. Here's the bad news, though. Provide you a lot of information can provide lots of loss and false positives. Example. Example 1. One is called, if anyone ever used a tool called Lint, okay, any programming language have a linter tool. A linter tool is, well, it's a static analysis tool. You send your program, you send your code to lint, it'll just identify all the ugly stuff. I'm going to take a copy of this. In JavaScript, there's something called Eslint. Okay, I'm going to start at the beginning. Here it is, var foo equals bar, and here's the things that I found. Foo is assigned to a value but never used, bar is undefined. Okay, I'm just going to copy to paste the stuff that we've been using. As you can see like requires not defined, response is never defined, not used, console is not defined, yada yada yada. Okay, you can do all so-called like rule configuration, and you can just say environment variables. You can say no eval right here, and that's what eval can be harmful. Exactly what we've been saying. Okay, so Eslint for JavaScript is Eslint that you can use. Also for JavaScript, another one. Facebook has a product called, as a developer tool called Flow. Flow is a static type checker for JavaScript. Tired of having running your code, Flow identify problems with your code, stop it and guessing. Okay, it's hard to build dynamic tools for like JavaScript. That's another example. Don't need this anymore. Example 2, Flow. Example 3. Example 4. Example 5. I don't think an example 6. I can give 6 examples here. So Flow is an example. Code bigger. Type inference. Alright, who's in Comp 105 here? Who's in CS 105? Remember something called a type checker? Alright. The type checker. You done the type checker yet, that guy? Okay. The type checker is a very good example of a static analysis tool. I'll give you a perfect example of why type checking is important. You know what latitude and longitudes are? What's latitude and longitude? Okay, Alan, what's latitude and longitude? What's the data type? Type for latitude and longitude. Should be like doubles or float or something. Well, in Google Maps, if you use the Google Maps API and you're using strings for latitude and longitude, map crashes. Yep. So I remember when I taught web programming for years, one of the labs in the course is to build a map of where everyone is, like the Marauders map in Harry Potter. And I can't tell you, I tell students all the time, make sure when you're storing data, when you're storing the latitude and longitude, it needs to be converted from string to double. And it has to be stored in a database as double. Else your map is not going to work. And a good 20% of course always screw it up. Real number is double. It just can't be strings. If you're sending using strings as latitude and longitude, there goes your program. Facebook also has infer. Infer is a static, here it is. If you love Java, C, C++, tool that have bugs in Java, JavaScript code before it ships. Infer is a static analysis tool. Infer lists potential bugs. There you go. You can use this for especially if you're an Android developer, Objective-C, for iOS apps. Lock Guide, Concurrency Racing Edition. It is a pain in the ass to install. I've done this before. Pretty cool. Okay. Infer. There's so many. There's a plethora of open source, free static analysis tools out there. Okay. GitHub. Talk about GitHub. GitHub also now has code scanning. Yeah, GitHub actually enables code scanning, static analysis. Okay. GitHub code scanning, developer first. Okay, yada yada yada. Code scanning generally now available for any project. Code scanning actually helps prevent security issues. Okay. Code scanning is developer. Da, 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 da. Scanned over 12,000 repositories, 1.4 million times, and found 20,000 security issues. Mode code execution, SQL injection, and cross-site scripting vulnerabilities. Pretty cool. Code scanning is now part of GitHub. Yay! You can also incorporate, here's the doc. Also, GitHub also now allows you to do third-party scanning. You can have like a sort of use third-party. These are commercial grade products. I mean, some of these commercial tools are world class. But the one I want to talk about next is my friends at Veracode. Veracode. I'm going to talk about Veracode. Veracode is a leading AppSec partner now. They're based out of Burlington, Massachusetts. Veracode was founded by Chris Weissoppel and Christian Ryu and members of the Loft team. Luminaries in cybersecurity. Want to give a shout out to Veracode. Want to give a shout out to Chris Weisoppel, Christian Ryu, and the Veracode team. Um, Interestingly enough, since 2013, Chris Weisoppel has gifted me and this security class and students access to the Veracode static and dynamic analysis tools. Really, really cool stuff. So students can learn AppSec and also what static analysis is. Um, Chris and Veracode have been a supporter of my security class and me for a long time. And part of this course, as extra credit, highly extra credit, is to encourage you to use static analysis on the 10th lab after the CTF. It's what I call legal cheating. You are strongly encouraged to use Veracode static analysis. For access, all you need to do is just send me an email and I'll give you access to it. Give it a try. Hold on for a second. analysiscenter.veracode.com. That's what happens. This is how Veracode static analysis looks like. So I have 3 projects here. 2 of them, like 3 of them, these are really, really, really old, really good project, good example project. It's also real too. Facebook. My favorite is the Facebook follower counter bot, which was written by Toddy Doyle many years ago. It's like 3-4 years ago. And I want to give a shout out to Toddy, wherever you are. I want to say I wish you well. Hope you're doing well. Yeah. So what you do is on Veracode platform, it's a start a scan. You can either start a dynamic or a static or a dynamic scan. All right, let's do a static scan. You create a new application. Enter all the information. Choose your business criticality. Your criticality will matter in the results. The experiment, you can experiment, play around with it. Of course, if it's a very low business criticality, it's not going to be as onerous as very high. And then you just upload your app after you do a save and continue. Results can usually take anywhere between 3 minutes to 3 days or even longer, so it depends what kind of an application this is. It does take time for Veracode to actually analyze your app. Now, here's the thing about Veracode. Oh, very important. You can either choose to upload a binary or the source code as is. Now, if you upload a binary, let's say like a game or something, what Veracode will do, what the static analysis engine will do, just reverse engineer the binary into code form. I mean, any binary can be reverse engineered into a code form. You upload the source code, just can analyze the source code straight. Okay? But once the static analysis is complete, you'll see a result like this. Anyone that have access to the system have access to the Facebook follower counter bot example. This is real. This is a real project. Here's what it looks like. Score of a 74 out of 100. It's not good. 74 out of 100 is not good. What's the report like? Why did it get a 74 and not like a 99 or 100? Here's what the static analysis engine found on Veracode. Oof. 2 very high issues, 2 code injection, no high issues, bunch of medium stuff. CLRF, cross-site scripting, cryptographic issues, directory traversal, server configuration issues. Yeah. That's your executive summary. Let's go to findings and recommendations. Code injection. Description of the vulnerability of the issue. Looks like you have eval. Oh, there we go. Looks like it's a case of eval being used here. Location, line 30 and 31. Improper neutral output CWE 117. You have cross-site scripting, CWE 80. There you go. Here's your example. Here's your where it was found, including the file, line number. Cryptographic issues. The list goes on. Directory traversal. Here we go. CWE 73. Now, one of the problems about static analysis is this. I gotta mention this. It's not only can provide a lot of false positives. One thing it doesn't do, what static analysis, okay, it can tell you the information, but can't prove it's a real vulnerability or that vulnerability exists. What I mean by that is this. What I mean by that is, okay, it will just say, okay, you're using stir copy, that's bad. You're using eval, that's bad. But it doesn't actually give you a precise example or the payload to say why it is bad. Okay? So it's not like what I did earlier, like when I showed you the C example in stir copy. I showed you why using stir copy is really bad, or why eval is really bad. Static analysis won't do that. It will just say using stir copy is bad, which it is. Using eval is bad, which it is, generally speaking. So static analysis can't really prove that it's a real vulnerability or vulnerability exists. It's like, looking at the code, this doesn't look good. Okay? So using Veracode static analysis, it can find quite a bit. I mean, including stuff like hard-coded usernames and passwords. I mean, using a static analysis tool or a code scanning tool is critical to if you're a developer now, because if you have millions and millions of lines of code, there's no way you can read all that stuff with your own human eyes. You gotta have like a tool that actually does that, that actually analyzes everything for you. You can't. There's no way a human being, a single human, can go through millions and millions of lines of code. No way. At all. So use static analysis as part of your tool chain. The other one, of course, now you've heard, is dynamic analysis. So what's dynamic analysis compared to static analysis? Code execution. Program must be running. Now the problem is dynamic analysis, unlike static, won't have 100% code coverage. I mean, when your application is running, you're only going to go to like certain parts of the app. You're not going to go to all the app. Okay? Which is valuable in its own right. I'll give you a very good example of what dynamic analysis can actually catch. Memory leaks. Okay? I mean, so dynamic analysis is valuable in its own right because the program must be running. I mean, although it won't have 100% code coverage, but it can catch some stuff like memory leaks. So, of course, here's a fun question for you, which I always like everyone to ask. Can anyone name a quintessential dynamic analysis tool? Oh, here's another example. This is so dumb of me, I didn't put down. For static analysis. You want to write your own static analysis tool, it's really easy to, you can do so. Anyone ever heard of something called grep? Yeah, you just write a program using grep and for a whole bunch of keywords, and there you go. Alright, static and dynamic analysis. You know of a tool that can catch memory leaks while your program is running? It's easily the by far and away, number one quintessential example of a dynamic analysis tool. I'm going to ask anyone. Hey! Valgrind. Yes, Valgrind. Is that still being used in the data structures course? It's still being used in 40, right? CS 40? Log out. I don't need this anymore. Excellent. It was me that actually pushed you using Valgrind in 15. 2011. Yeah, I taught 15 for 2 years and they kicked me out. Just got that. Fun times. Dynamic analysis, Valgrind. Very famous example. Okay? So now, that's all I got for today. Today's pretty straightforward. Bad code, static and dynamic analysis. That's all I got for today. Ties in very nicely. This is actually, the static analysis will tie in very nicely now that the capture the flag is over. The game is over. And I'm giving you all the source code to play with it. Again, for the 10th lab, the technical risk analysis for the security course, you can legally cheat and do the lab. It is strongly encouraged that you legally cheat and you get access to Veracode. You do that, you run that thing, and then you get extra 0.5 extra credit anyway. Now, why? Why in the world did I actually talk about static and dynamic analysis today? There's a reason for it. Not only is now static analysis is very important for programming, important for cybersecurity, ties in very nicely after now that the captured flag is done. But one more thing. Yes, you do need to email me. Yes, good thing that you read the instruction. Email me to get access to Veracode. You know where this is going. There's a reason why today I covered static and dynamic analysis. Because this all leads to one last major topic in the course. And what you really do need both static and dynamic analysis. You know what that topic is? This one last topic, you need to know everything that we've done in this course so far. Networking, packets, password cracking, vulnerabilities, maybe even a little bit of web security, static analysis, dynamic analysis. One last topic that encompasses everything. You know what that topic is called? Anyone? Take a guess. Start with a letter M. Nope. Start with a letter M. The final topic, the final big topic of this class. Nick said it. It's malware. Don't need this anymore. Ink droppings. See you next week.